serverless comrades. My name is Ahmed Shams, and I'll be covering Google Apigee for API management with Polyglot API runtime. Well, what do I mean by that? We have a vision in our organization where we want to build an API ecosystem to increase data sharing, right? And we talked about it earlier. We want to reduce the integration cost when people are sharing data and improve the time to market. The current status quo and the problem statement is we've got this spaghetti that really doesn't work for us, so where we have got this point-to-point integration going from one end to the other end, and these are getting hodgepodge, and you would have to rewrite the same integration again and again for different endpoints. We want to move away from this. We know the challenges that this brings, and it's not sustainable. And the challenges even made bigger by developers that says, hey, I do know how to do this integration and point-to-point integration right now, but you're telling me to build an API. Can I keep using the languages like Python or Java or Django that we like to use to build the APIs? Because I really don't want to learn new technology in the process. Well, we have to solve that problem too, and we came up with a solution where we are saying we'll have a central hub for having your all data exchange solution rather than doing this point-to-point integration. Everyone should be able to come and find what are the data exchanges out there, and we want to get to it right away, and we want to start building APIs and apps as quickly as possible. There's two groups out there, a consumer of the API and a producer of the API. Producer has a very unique problem. They want to build APIs using the technology that they can use and they are very familiar with on a day-to-day operation. Well, our solution couples together a couple of technologies and brings them all together to have that and make that possible. We say you build your API using Docker, which allows you to use the language and the packages and the libraries that you like to use, and you only worry about getting to the backend and your data sets, and leave the worrying of doing an API and API management and security and transformations and all sorts of bells and whistles that comes with managing an API program. Leave it all off to Apigee and publish it in the portal that comes built in from Apigee, and just manage and just worry about writing the simple code that goes to your database and does all of this. In this presentation later, I'm going to demonstrate the whole end-to-end cycle for one use case, but that could be expanded overall. The idea here is on the right-hand side, as you can see, AWS. That's where you will be building your APIs. And on the left-hand side, you see Google Apigee. That's where your APIs are going to be managed, which makes it very, very much simpler rather than having to deal with the whole management plane also. Now, at this stage, what we're saying is Apigee is going to be the one that the consumers are going to interface with. Producers are going to build the backend API using Docker and underlying technology that they're familiar with, publish those APIs in ECS. They could also use Fargate, but in this case, we're just going to cover ECS, and then expose those APIs to Apigee in a secure manner. The way we talked about securing this is using the public ALB. We're going to demonstrate that in a short while. I'm going to go step by step, take you through this process to see how this could be done. The very first step in this process is let's set up an Apigee account. All right, so how do we do that? Let me go to my browser if I can find it here. Right there. All right. So if you wanted to create an account, you'll end up in this Apigee free account, and you can say create an account, and they will be able to give you this. I have posted the URL in my document where you can see how to go create this account. For me, and once you create an account, a free account, you should be able to log in, and I'm going to log in, sign in right now. Of course, during the presentation, it's giving me an error. I will just refresh the page, do it again, and I'll get in. The very first thing that we're going to do is build a proxy. Now, Apigee gives you some dummy endpoints. We're going to use one of those endpoints. By dummy endpoints, I mean over here, as you can see, there's a dummy endpoint. And if I were to call this endpoint right now, I'm using Postman for my APIs. This is a tool that you can download and use. I highly recommend anyone who's dealing with APIs to use Postman. It's free to use for the individual level. So I'll just call this API, which doesn't have any bells and whistles. All it does is it spits out to us what's the header information, where is this call coming from, what is my IP address, and so on and so forth. There is nothing fancy about this API. So what does an Apigee proxy mean? So let's go see that. We're going to go over here and we're going to say, hey, let's create a dummy proxy. We say reverse proxy, dummy proxy, and we're going to put the mock URL. Next, we're just going to pass it through, no security whatsoever. The other one did not have, so why should we have security here? Publish it in test, create and deploy, and off you go. That's the URL you're getting now. Let's see if we can hit this URL. And let's go back to Postman, mock Apigee URL. I'll post that URL here. It's a GET call. Let's see what happens. Wow, it works. Well, what's happening behind the scene? What does Apigee bring to us on the table? Over here, I can see what that new URL is that you'll be publishing to the customers. You have a development plane tab that lets you do development and add policies. These are bunch of policies that Apigee gives you out of the box, and we're going to show you some of those policies in a second. But it gives you this nifty tool, lets you trace what's happening to my API. If I just turn on the trace and I call right here and go back, this trace got generated. And each step of the way, it shows you what were the results, what are the data that was coming in, and what was happening to it. Let's modify this. Let's apply a policy. Hey, I don't like this output in JSON format. Can I apply an XML? Can I get the output in an XML format? Well, let's say there's a policy called JSON to XML. Awesome. Let me apply that over here. There's two things. There's something called pre-flow and a post-flow. Pre-flow are things that happens before your API gets called, and post-flow that you would like to do maybe some transformation to the data after your API endpoint is called. So in my case, I want to convert the result set. So if I want to convert the result set, it goes to post-flow and save, and let's run it again and see what will happen. There we go. We're going to run this Apigee endpoint again. We're getting it in XML. If we hit the original one, we still get the JSON. So all of a sudden, you applied a policy, and that's where the power comes in. The power comes with Apigee, which gives you lots of pre-built policies that you can apply. And you can also write your own policies using JavaScript, Python, Java callout. These two are grayed out because we are in a free version, but if you are in a paid version, they come readily available to you. It has its own capability to store credentials and attach them. Possibilities are just endless. Can I secure this API? Well, let's try to secure this API, and I'm going to say, hey, I want API key. Verify API key. Oh, that's JOT. That's not the right one. Let's say verify API key right here. And I want to verify the API key in the pre-flow before anything gets called. So just save it. And if we call the original API right now, it should still work, but the moment it's going through Apigee, it has failed. Now it requires an API. So this is a very, very basic introduction of Apigee. For the essence of time, I'm going to go on to building our first API proxy. You've seen me do API policies, and I've shown you how to secure one of those policies, right? Not that we've done anything with it. Now let's build a backend. Well, let's build a simple Flask using API using DynamoDB. Now I'm going to show that to you quickly what I've done over here. I'll be commenting out some of these credentials. I obviously don't want you to steal my credentials from here. But this is a very simple API. We've seen it has a base route that just says ping from Flask hello demo. It has another route that goes to our DynamoDB table, and the table name is music, and pulls out all the records from the DynamoDB table and displays it when you get to this endpoint. And then there is a third endpoint that we created that lets you do a post. If you pass in the artist and the song title, it will post the artist and the song title into the DynamoDB table. And that's simple. It runs on port 5000. So let us run this and see what we can get. I have already taken the initiative of running this program. All I had to do was Python 3 app, and it's running on port 5000. So I'm going to test this out if this actually works. And let's go to this call. I'm going to call it local. As you can see, music. Call it send. That works. I'm going to call the other endpoint also. So let's duplicate this right here. I'm just showing you how to use Flask. Also open in a tab. I'm going to say Flask app local post, right? We're going to have a body in that. It's v1/music, and the body is going to be JSON. Oops, I have to say post. And we are not going to have none. We are going to do form data. No, I know why. I have not selected content type is JSON. So I should say content type JSON, application JSON, right? Go to the body, have a body. What it does? Right? Raw. And I'm going to have, what are the two variables? Do you guys remember? Help me out. It was artist and song title, right? So I'm going to put artist and song title. And the artist is going to be, let's just say, Dr. Dre, Eminem. Let's do Eminem, right? And the song title is going to be, Slim Shady, let's just say. Slim Shady. And that's the call, and it should do it returned it back. Now, if I do a get call of this, I should be seeing the Slim Shady back. So let's just make this call again. And I have album illustrated John Lennon, somewhat famous, song Shams, Eminem, Slim Shady. That all worked out fine. Now, the very next thing we're going to do is we will have to create, I'm going to stop this program right now, and we'll have to create a Docker image. Now, I have Docker running on my machine. We have covered this numerous times in our class, so because of the essence of time, I'm not going to cover how to create a Docker file and how to tag it and how to put it up in the ECR. This has been covered very many times in our class. You can go back to those lectures, or you can go back to my document, which takes you by step that shows you how to do this. But one important thing that I wanted to show you was in the demo was how to build an ECS cluster and how to build an ALB and how to deploy a Flask app that has been uploaded there to do all of this. And that could be done very easily by having access to AWS console. I'm just going to refresh to get in there. And this is my account. I'm going to go to AWS console, and the very first thing you want to do is ECS create cluster. The moment you say create cluster, it'll give you this option. I'm just going to walk you through them, but I'm not going to create a new cluster right now. You can name your cluster class demo, but I'm not going to create this, as I said. You can choose your instance. Be careful of what you choose. You can choose a T2 medium. That'll be more than sufficient for you to do. Obviously, for demoing, we're doing one instance, but you might want to have 2 or 3 in your cluster. And then, oh, I did not choose T2 medium, and then so on and so forth. If you want to do SSH into your machine, might want to create. I would not recommend you create a new VPC. You might want to use your default VPC, or you might want to create a new VPC for this cluster that will do communications, and that will have its own policies. You could do that too. You can have a sitter block. You don't have to worry about much of this stuff. The security group inbound rule is that your cluster would be allowed to have traffic coming in at 80, right? So if you are doing 443, you would have to go open up those policies later on. And then you just do create, and it'll create the cluster for you. Once the cluster has been created, it'll give you, I believe there's one more step in that. Oh, I ended up creating a cluster. Anyways, I don't care about this right now. I'm going to delete all of this stuff at the end of this session. I'm going to take you back to ECS, EC2, and I want to show you what will end up happening in EC2 the moment you create a cluster. So when you create a cluster, you'll see a couple of instances show up in your ECS and EC2 instances. Right now I have one. There will be one more that will show up in a very short. And once you have the cluster, you would be able to create what is known as you'd be able to create load balancers and target groups. I would recommend you create a load balancer, right? I have already created this load balancer, and I can show it to you. Or the way you'd go about it is create load balancer, and you say application load balancer, and you name your load balancer, and it will be internet facing. And what are the traffic that you're going to allow on your load balancer? Basically, on what ports are you going to be allowing 80, 443, and so on and so forth. Once you do all of that, once you go through the whole cluster creation process, you'll have a cluster just like how I had shown you earlier over here. And if I go to this cluster right here, you can see I have the information, I have the listener information, I have the monitoring information, integrated services, once I assign this cluster to anything else, and any tags that you've given. It's basically a cluster. And then you'll create a target group. The target group is basically telling what it will run and what you're attaching to this, right? In my case, I created this target group, and I had attached the EC2 containers over there. And the other thing that I wanted to show you was the EC2 instance, right? So EC2 dashboard in my instance, see there's another one coming up, which I did, the cluster that I just created. I have to delete this, obviously, using. If I go to this and I go to security, you can see in my EC2 instance, I have allowed access to port 5000 because my app is going to be running in 5000, so it should enter my EC2 at 5000, and then I'll be running my Docker instance inside that, which will be listening in on 5000. After that, after this is all done and your cluster is built, you can go to your ECS console and make sure you have the old one selected. Like if I go to like my final project 2 that I created, they have this new UI. I haven't figured out how to use that, but I'll soon figure it out. What you'll be doing is you'll be creating a service. Now, presuming at this stage you already have your ECS, ECR, basically your Docker file uploaded in the ECR, and then you create this service. You choose EC2, you choose the project, you choose all the information over here and how many number of tasks you'd be running. In my case, since I only have one EC2 instance, it would be only one task, and so on and so forth. And after I publish all of this, I would be deploying in next step, deploy, and what you see would be your Flask Docker running over here. How would you get to this Flask Docker? Because you can't hit your endpoint. That's where the load balancer comes in. Again, I'm going to go back to the load balancer EC2 instance. Remember, the load balancer stuffs are in EC2 instance. The load balancer is a type of compute. So if I go back over here in the load balancer, I have in the description, you see all the subnet and security groups and all of that sort of stuff. And if I go over here, the DNS, listeners, and I have this DNS name for my load balancer. So let's see if I can get to this API using my load balancer. And that's what I'm going to be doing. And over here, I'm just going to go call the same one, but I'm going to be doing my load balancer. right? And let me do a send, and it gets called. That's the end of the first part of this presentation. I will have another small presentation that